I'm using a new pony motor. It's a 1/3 horsepower RotoVertor. And it's that same one I've been testing a lot. Marathon brand. And here's the one with the rotor of neodymium magnets slanted at 35 degrees. I have only 2 magnets there at 180 that are spinning around. Not 4 magnets, only 2. And I've got this to now run off of 60 hertz, which was kind of my goal with this. However, it's getting a little hot, and I imagine it's because the magnets are too close to the laminates, that they're about this close. Probably should pull them back to about like that far away. I have a 35 UF run cap here. I started out with a 4 UF and I got the draw down a little bit, but it's still drawing way too much. It's like 2 amps over here. 2.1 with this. So that's like 120 watts. Ridiculous. And but it's running on 60 hertz AC. I might be able to get the draw down more, but not that much, because this one only draws 50 milliamps while it's turning this. Well, it's connected by shaft to shaft, and it's spinning this, and it's still only drawing 50 milliamps at 120 volts. And also I shorted out a phase from this. This is working as a generator, and the draw to this goes up 120 milliamps, up to 120 milliamps from 50 milliamps. So that means there's lens breaking going on here when it's working as a generator, and it's something I wanted to know. And these are really good motors to test for lens breaking in generators, because they're very sensitive to shaft load RotoVertor motors. So I figured that out. It does have lens breaking. I expected it to. And also, I wasn't really expecting this to be able to run on AC, but it does. And I will show you that. So the way I'm doing it is I plug in this motor to 120 volts, 60 hertz, get this going while it's spinning this just as a shaft load at first. And then I hook this motor L1 to L1, L2 to L2, and it has its own run cap, and this has its own run cap. And you have to make sure this is going to be spinning the right direction, of course. So it does when you do L1 to L1. So what you're going to see is I'll start this up, get it going, and take my word for it, it's drawing 50 milliamps. And then when I hook this up so that it's also drawing from the same power supply, and both motors are running from one power supply, this is going to be drawing over 2 amps, because I have a ammeter between the L1 of this motor going over to the L1 of this motor. And then I'm going to reach back here and disconnect L1 to this motor. So now this motor will not be powered, but this one will be, and it'll be spinning this as a shaft load. So I begin by powering this motor. This is the shaft load. Then I connect this motor so that we have both motors running off the same power supply. And then I'm going to disconnect this motor, and only this motor is running off 60 Hertz AC. And that's where it's actually successful, because this is running off AC. The rotor in there is 2 magnets slanted at 35 degrees. Go 2 videos back, you can see what it looks like. And they're 180 degrees to the magnets. So here we go, hold on. Okay, here we go. This motor's drawing about 50 milliamps, take my word for it, 120 volts. If I short out one phase of this motor over here, it's going to go up to 120 milliamps. So that's the Lenz's law of braking action. So I did that. Now this has a 35 UF run cap to here. This has a 4 UF here. Now the L2 line, everything's hooked up so that it's going to run on the same power supply into both motors when I hook this up to here. There we go. Now, the amps it shows is what goes into this motor here. That's a lot of amps. And I feel some heat over here. Usually these are like cold. In fact, colder than ambient rotovertors when you get them right. But this has got some heat going on. And I'm sure it's the magnets going past all the iron in the laminates. I'm not sure, but I guess so. Now, what I'm going to do is disconnect. Right now, both motors are drawing the same, from the same power. But I'm going to disconnect this L1 line from here. There we go. That is disconnected. Now we're only powering this motor. Only this motor is taking the 120 volt 60 Hertz. And there's so much power in this thing, or whatever it is, that when I disconnected this motor as a load, as a shared, when this was sharing power, and I took this out, you'd expect the draw to go up here, but it just stays the same. When I take off a run cap, disconnect the run cap 35, the draw goes up. Now it's connected, so there is, the run cap is affecting draw to this motor, but I feel heat. And it shouldn't be like that, but this is running on 60 Hertz AC, this motor. That magnet configuration of only 2 magnets, it works at AC. However, you can't do it like the RotoVertor where you use a start cap and you bring it from stop with a start cap. You can't bring this from stop. Maybe I could if I get just the right magnet configuration so that the rotor resembles what happens with this induction rotor. Anyways, so it's working. It's working, just drawing too much right now. So I think I'm going to put a new rotor in, and instead of the magnets about this far, because they're really strong N52 magnets, instead of about this far from the laminates, I'm going to make them like about that far. And I guess that's about it. At least it works. Now a little refinement. Oh, I wanted to show one more thing after I turned it off. I want to show how I made the shaft a lot stronger. Hold on a bit. So I reinforced this shaft of stainless steel threaded rod, which is not the strongest in the world, but what I did is I reinforced the shaft like this that goes inside, and so the shaft's stronger, still not like this shaft, but it is what it is. And I got roller skate bearings in there, and there. And you can see about how it spins with the magnets in there. About like this. Oh, this one, no magnets. Spins about like that. So, okay, well, that's the video. Thanks for watching.